Now, so in earlier class we have discussed that two charges were completely filled with dielectrics. Clear? This is completely filled with dielectrics. So now let us take partially filled. So this is case 2 when dielectric is partially filled between the charges. Are you clear? So now what I will do, I will consider this is one charge, first charge, and this is second charge. Let's say R is the distance between these two charges. This is the first case. And in second case, what I am doing? In first case, we have taken total dielectric between this first charge to last second charge. Now I will be considering only half part. Let's say T is the thickness of the material which is placed between the two charges. What remains here? This is R minus T remains. So the total distance between two charges is R, and you have introduced a dielectric constant, dielectric material whose thickness is T between these two charges. Clear? So before adding dielectric constant, so if you take the two charges, then definitely there would be a maximum electric force exerting. So as soon as the dielectric is introduced between the two charges, then the force is going to decrease. Effective force is going to decrease. Now what will happen? To decrease the force of attraction between the two charges, here are the two important methods. One is, what I am doing? I am increasing the distance by removing the dielectric constant. To achieve the decrease in the force between the two charges, by removing the dielectric constant, and we are increasing the distance. Let R dash be the increase in the distance between the two charges. If you increase the distance between the two charges, what will happen? Because F is inversely proportional to R square. F inversely proportional to 1 by R square. So as the distance is going to increase, then what will happen? Force is going to decrease. So now before that, let us write Fm is equal to 1 divided by 4 pi epsilon naught K. K is the dielectric constant here. Clear? So this is Q1 Q2 divided by R square. Q1 Q2 divided by R square. So this is the force, or you can say electric force between the two charges when dielectric, or you can say medium is introduced between the two charges. Let the dielectric constant, that means a dielectric material is removed and the distance is going to increase. Then what is the force? That I will write. Yes, F dash, F is equal to, not F dash, F is equal to 1 divided by 4 pi, okay, 4 pi epsilon naught Q1 Q2 divided by R dash square. So this is the force in which after the removal of dielectric constant. Now what will happen in these two cases? The case 1 where we are removing the dielectric constant, and case 2 we are increasing the distance between them. By doing so, what will happen? These two forces will become equal. That is, F is equal to Fm. So F value is 1 divided by 4 pi epsilon naught. So no need to remember this derivation, just I am showing you the formula how it comes. If you remember the formula, that's enough. 1 divided by 4 pi epsilon naught K, then Q1 Q2 divided by R square. What are the terms that can cancel here? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. q1 q2 q1 q2, then 1 by r dash square is equal to s, what will happen, 1 divided by k r square. Then take it to numerator, what will happen, k r square is equal to r dash square, r dash is equal to square root of k into r, we can write. So that means r dash is what? This is the effective distance. As the distance is going to increase, then what will happen? Force between the two charges decreases. So by introducing this constant, so this r value is what? It is considered to be a thickness of the material. Now the force will become, the new force will become F is equal to 1 divided by 4 pi epsilon naught, then this is q1 q2 divided by, so r minus t plus square root of k into t, this is whole square. So this is very important formula. Special case when you are placing the dielectric constant partially filled. Partially filled means, I will take one example so that you can understand this. You remember the formula, F is equal to 1 by 4 pi epsilon naught q1 q2 into r minus t plus square root of k into t square. Clear? So now let us go for one example. Example is, the force between the 2 point charges are placed at a distance r is F. Find the force between the charges if the half the space between them is filled with the dielectric constant 4. So here this problem is divided into two parts. One part is, we have two charges, q1 and q2 charges, and of course they are separated with certain distance r. When they are separated with certain distance r, what is the force here? F is the force between them. The force between 2 point charges are placed at a distance r is F. R is F. Find the force between the two charges if the half of the space between them is filled with a dielectric constant. So now in the second case, what will happen? S, half of the space. This is half of the space. Half of the space. T is equal to, you are taking r by 2. So here r is the total distance between the two charges. Clear? So what will happen? Remaining part r minus t means t value I am taking r by 2. Are you clear? So your formula is, what is the new force? In this case, what is the new force they are asking? Of course they have given when two charges were separated with certain distance r, this is F is the force between them. Then what will happen if the two charges were placed with one dielectric constant whose value is, k value is given, how much it is? K is equal to 4, and its value is also given. Thickness is, say for example this is 1 meter distance. If r is the 1 meter distance, then what is the thickness? 0.5 meter. That means it is r by 2. It is taking value of r by 2. So now we know that, what is your formula? So F is equal to 1 divided by 4 pi epsilon naught. So q1 q2 divided by, what will happen here? R minus t plus square root of k. So t value is, I will write as it is this formula first, then I am going to substitute this. F is equal to 1 divided by 4 pi epsilon naught. Now q1 q2 divided by, so this is r square. So r value is r minus t value is, this is r by 2, and plus k value is given, that is 4 dielectric constant, and t value is again this is r by 2 whole square. Are you clear? So in next case what will happen? Definitely I will take next page. So F is equal to 1 divided by 4 pi epsilon naught. Clear? F1, Q1 Q2 divided by, this is r minus r by 2 means what? R minus r by 2. So when you take r as common, 1 minus 1 by 2, that is r into r by 2. Are you clear? So if you go back, what is the value here? R minus r by 2. That is, this is r by 2, and here this is square root of 4 is 2. Then what will happen? R by 2 remains here. R by 2 remains. So next, what I am doing? This is r by 2 plus square root of I'll write one more time. F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by, so that is r by 2 plus another one more is s square root of 4 is 2 into r by 2 whole square. Now F is equal to 1 divided by 4 pi epsilon naught. What happens here? Q1 Q2, this is new force, F dash we can call it is. So this is 2 to get cancelled, then r by 2 plus r whole square. R by 2 plus r whole square. Next, F dash is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by, so this is r by 2, so cross multiply, this is 3r by 2 whole square. Are you clear? So now what will happen? F dash is equal to 1 divided by 4 pi epsilon naught, so value of this one is q1 q2 divided by, so r square I will write separately, this is 3 3s are 9, this is 2 2s are 4, then what will happen? 4 goes to numerator and 9 comes to denominator. Then this value is what? F. Of course it is F dash is equal to 4 by 9 into F. Because you know, in the formula itself I will take F dash because F they have given. So F is the force, that is F is equal to 1 by 4 pi epsilon q1 q2 divided by r square. That is what? Maximum force when they are placed in the vacuum. So now what will happen? When these two charges were placed in vacuum, what is the maximum force? 1 by 4 pi epsilon naught, that is q1 q2 divided by r square. This is the formula. Clear? That F is nothing but what? This is the maximum force. So when these two charges were placed, or these two charges were filled with dielectric constant of k value 4, then and its thickness is half of the total distance, that is r by 2, t is equal to r by 2. Then what is the new force? What you are going to calculate? New force exerting between the two charges. Are you clear? So we have substituted, we have taken the formula. This is a special case, this is a special formula. Just you remember, no need to remember the derivation, how it comes, just you remember the formula. So this is the formula where when two charges were placed with when two charges were inserted with dielectric constant or dielectric material. So F dash is equal to 1 by 4 pi epsilon q1 q2 divided by r minus t plus square root of k t whole to the power 2. So and t value we have taken r by 2, okay, r by 2, then we have substituted, then ultimately we have got totally this force value as F dash is equal to 4 by F. I hope you understood this. Are you clear? Okay.